So in this video, we're going to be talking about multiple representations. So there's two parts to the foldable. There's one of two, right? It's just part one, and then two of two is going to be part two. So have both of these ready for the video so you can fill these in as I go. If I talk too fast or write too fast, then just pause the video so that you can catch up with me, okay? All right, so if I open up this first one of two, I'm going to see that there are four parts to this. There's a word problem, a table, an equation, and a graph. And really, these four things are all representing a relationship between a set of numbers. They're just different ways to represent it. Okay, that's why we're calling it multiple representations. All right, so the first word problem says that Samantha can make 36 cookies each hour. Make a table and graph to represent this relationship. Then write an equation to find the total number of cookies, C, that she can make in each hours. All right, so if I read the word problem again, I'm noticing here that she can make 36 cookies each hour. Well, each hour is just in 1 hour, right? All right, so in 1 hour, she makes 36 cookies. So in 2 hours, how many cookies would she make? Well, how do I figure that out? I'm going to multiply 36 times 2. And that gives me 72. All right, so she keeps baking. In 3 hours, she's going to make another 36 cookies. So I'm going to multiply 36 times 3 with 18, carry 1, 108. All right, and then for 4 hours, again, I'm going to multiply 36 times 4, so 24, carry your 2. 3 times 4 is 12, plus 2 is 14, so this is 144. So in 4 hours, she makes 144 cookies. And then here, I'm saying, okay, the nth term, that just means any term that comes after 4. What's the rule? How do I get from here and the input to the output here? Well, every time I did what? I multiplied by 36, so that's my rule. Now, normally we use x right here. We would say 36 times x, okay? We would call this x here. But this one's a little different. Sometimes with word problems, they use different letters to represent what we're talking about. So, and the input is the number of hours. So this is like each. So it doesn't matter what this is, what number here, how many hours she bakes, right? We're always going to multiply that times 36. So instead of writing 36x, I'm going to write 36 times h. Okay, so I know if I want to make an equation, I have to have a what? An equal sign. All right, so again, normally I say y equals something because I want my output to equal my rule. In this case, instead of calling it y, I'm going to let it represent something from the problem. So really, what is she doing? She's baking cookies. So the number of cookies that she bakes is equal to 36 times h. I can write it with parentheses, or remember, I don't really need those parentheses. I can just write it as a number next to the letter. Both of these are correct, so you can kind of choose how you like to write it. All right, so that's my rule. My output is equal to 36 times my input here. All right, so the last part is to graph the equation. So this graph is labeled, but it's not numbered. So I'm going to have to do that part myself. So if I look at the numbers, I know that h, that's this down here, is going to have to go from 1 to 4. So I'm going to label this as 1, 2, 3, 4. All right, and then these numbers go a lot higher, and so I know that I don't have 144 spaces there, and I don't really want to number to 144 either. So I'm going to let these increase by 10 instead. So 10, 20, 30, 40, 50, 60, 70, 90, 100. So I am going to take this all the way up to 150. And you have to write pretty tiny, so be careful there. All right, and so now when I get ready to graph this, the input, the h is 1, and the output is 36. So I'm going to go over to 1 and go up to 36. Now I know 36 is really somewhere in between 30 and 40, so I'm just going to kind of guess where I think that might be. 2 and 72, I'm going to go over to 2, and then 72 is a little higher than 70. 3 is 108, so that's not quite all the way to 110. And 4 is 144, so a little past 140. Okay, and then I can see that these points are lining up to make a line, right? We saw that in the last stop that means that this is a linear relationship. So that's important to remember. And again, if I look at the graph, this is my input, so this is also my independent variable down here. And then over here, these are my outputs, so this is going to be my dependent variable. Dependent. Oh, I'm not spelling this right. Dependent. Sorry. Okay. And then for those of you you remember when we were looking at proportions, we talked about how a relationship can be proportional. So if you want to keep something in proportion, if you shrink it, you've got to shrink everything the same amount. So if you're shrinking down the actual size of a person into a little miniature statue or something like that, you want to shrink the arms more than you shrink the legs, or it doesn't look right. Well, proportional relationships are also represented in graphs too. We didn't talk much about this when we did proportion, but you're going to see a lot more of it in 7th grade. So just to kind of plant that seed, if a equation makes a line and it goes through 0, 0, so we can see that in 0 hours, how many cookies is she going to make? She's really going to make 0 cookies. So if a line goes through 0, 0, or the origin, that's also what that's called, and it makes a line, and this is also a proportional relationship, not just a linear relationship, but a proportional one. All right? So let's look at the next one. The student council is holding a car wash. Sorry, I'm going to fold this over. To raise money, they are charging $7 for each car that they wash. Make a table, a graph, and then write an equation. Right? And when they want us to use t and c. So instead of x and y, we're going to be using those variables. All right, so $7 per car. So one car is going to be $7. 2 cars, that would be 2 times 7, or 14. 3 cars, 3 times 7, or 21. 4 cars, 4 times 7, or 28. So what am I doing? I'm taking c, and I'm multiplying it times 7. I'm going to write that as 7 times c. All right, so my equation, again, has to be an equal sign. Normally, I would say y equals, okay, but this time it's not y, it's t. So I'm going to write t equals 7 times c, or t equals 7c. And then the graph, I'm going to use these to graph. So again, I'm going to have 1, 2, 3, 4 as my input. And then I've got to go all the way to 28 for my output. So I'm going to go up by, let's say, 2s. 4, 6, 8. All right, so 1 and 7 is somewhere between 6 and 8. 2 and 14 is right there. 3 and 21, about right there. 4 and 28 is right up here. All right, so again, I can see that this is forming a line. All right, and if I think about it, so this is linear. I can see that my independent, my input is down here, independent. This over here is my dependent, or my output. All right, and then because I brought it up in the last one, I said, all right, what makes a proportional relationship? It has to form a line. Okay, would this line go through the point 0, 0? Well, think about it. 0 cars, is it 0 money? Yeah, so this is also going to go through the origin. So not only is it linear, it's proportional. All right, look at the next one. So this is multiple representation, right? Part 2. Galaxy Bakery sells cakes for $7 each with a delivery fee of $27. Make a table and then a graph and then write an equation. All right, this time I'm using t and c as my variables. So this time it's not just $7 per cake. I'm also going to have to be adding a fee. All right, so one cake would be $7. I'm going to have to write this over here. So one cake would be $7, but then I have to add the fee to deliver it, $27. So 7 plus 27, 34. All right, so in the next one, if there are 2 cakes, okay, not only do I pay the 27 delivery, I have to pay 2 times 7. So I would do 2 times 7 plus 27. So 14 plus 27 is 41. 41. All right, for 3 cakes, I have to do 3 times 7, which is 21, right? And then add the delivery fee of 27. All right, so that would be 48. The delivery fee is really not changing because it's not like they have to drive an extra route to get it to you. They're already coming to your house, so you're going to only pay for that once, but they're going to charge you more for the cakes because they're making more cakes for you. All right, so 4 times 7 would be 28, and then if I add the 27, I get 55. Okay, and then if I'm trying to find the rule, what did I do? I multiplied it by 7, and then I added 27. All right, so what was I multiplying times 7? The number of cakes, so that would be 7C, and then I had to add 27, the delivery fee. So go ahead and make that into an equation, which needs an equal sign, and again, I'm going to use T as my dependent variable is equal to 7 times the number of cakes plus the delivery fee of $27. All right, to graph this, I'm going to do 1, 2, 3, 4, and then I'm going to go up this time, let's say by, I don't know, maybe 5s. So 5, 10, 30, 35, 40, 50, 55. Okay, so one cake is $34, so I'm going to go almost to 35. 2 cakes is $41, it's a little past 41. 3 cakes is $48, so not quite all the way to 50. And 4 is 55, so I'm going to stop at 55. All right, so again, this is my independent variable. This is my dependent variable. Is the graph linear? Yes, it's linear. All right, but is it going to go through the origin? If I continue this line, does it go down here? Nope. This is not proportional. It forms a line, but it doesn't go through 0. It doesn't go through the origin, so not proportional. And that's really because of the delivery fee, right? All right, so Juan's family pays $3 per taco plus a delivery charge of $5. Make a table. Represent it with an equation. So again, $3 per taco, so it's going to cost me $3 for 1 taco plus I have to pay the delivery charge. So I'm going to say, okay, well, 3 times 1 taco plus $5, that's 3 plus 5, which is 8. If I buy 2 tacos, I need to multiply times 3 and then add the $5, so that's 6 plus 5, which is 11. I buy 3 tacos, 3 times 9 is, or 3 times 3 is 9, then add the $5 to get 14. And then the fourth one is 3 times 4, that would be $12 for the tacos plus $5 to deliver it would be 17. All right, so what was I doing every time? I was multiplying 3 times the number of tacos, in this case that's T, and I was adding the delivery fee plus 5. So my equation, go ahead and write that. As an equation, what is equal to 3T plus 5? C, the cost. So the cost, C, 3 times T plus 5. All right, and then we want to graph this. So I have 1, 2, 3, 4 down here. I need to go up to 17, so I think I'm going to use 2, 4, 6, 8, 10, 12, 14, 16, 18. Right? So 1 taco is 8. 2 tacos is 11. 3 tacos is 14. 4 tacos is 17. So between 16 and 18. Okay, so here are my independent. Here's my dependent, right? Input, how many tacos? What does it cost, dependent? All right, is it forming a line? It sure is, so it's linear. Does it go through the origin? Does it go down here through 0? Nope, so it's not proportional. All right, so that's multiple representations. You're taking a situation from a word problem, for example, and you're figuring out a table, how to figure out how to answer this question using a table. All right, you're also figuring out what the rule is for that table and making it into an equation, and then you can use that to make a graph as well. So all of these representing this relationship between the amount of tacos that you get and the cost of those tacos. All right, so that's it for now. Have a good day. Thanks.